to Mr. French.
Hello.
Right, who's going to illuminate us on the ins and outs and the wiles and ways of DTrace.
Okay.
Yes. All right.
Thank you very much. I'd like to thank all my hosts. Thank you, Tech Systems. Also, I want to thank Andy. Andy does all of the audio and video, and I have had so many presentations go so poorly in the past. I'm always like, what's the screen resolution? What's this? How far away from the microphone do I need to stand? And he was very calm. He said, okay, man, I'm going to answer all 4,000 of these questions. So
let's see if it gets published. Okay.
Let's see if it gets published. Okay, yeah, that's not my problem. Okay, all right, DTrace. Let's talk about computers, why they're bad, the problems that are facing humanity. This is a very fraught time in society, right? Not just domestically, but also internationally. Mainly the biggest single threat that I see to humanity right now is that computers are too complicated. They are too hard, and there are too many of them, right? So we have all these computers running around being obtuse, being opaque, doing things that we don't understand. We claim to understand them so we can get our paychecks, but we don't. I mean, I don't. Maybe y'all do, but I do not. So whose shoulders? Who's at fault when the computers go bad? It's us, right? So, and sometimes we mess up, right? And we don't want to mess up. I know that I have had that day before where you see the logs or you hit the keystroke and you realize that sinking feeling and you say, oh, the rest of the day is not going to be as good as the previous part of the day. It's about to get bad. So what is the solution to these problems? The problem of too many computers and they're bad, right? The single solution, there is only one solution, right? I've come to you with the ultimate solution: observability and debuggability of live production systems. This is also known as dynamic tracing. And so here are some, so I'll tell you a little bit what this is. This means instead of taking a core dump and looking at it or digging through logs to figure out what happened, you walk right up to a production system and safely instrument it without crashing it and without slowing it down, right? So we're familiar with, like, you can make a SQL query against a production table, and as long as the database doesn't have any problems, that SQL query probably, if it's a select, won't crash the database, right? It might slow it down so that it can't service anything else. So that's another thing that we want out of dynamic tracing, is not just that immutability, but also an upper bound on the amount of cycles that we can steal from the production items. So there are tools that on Linux for this. You may be familiar with ftrace, or eBPF is sort of the new hotness there. On Windows, you get event tracing for Windows, and on the BSD derivatives, there's something called ktrace, but these are all effectively the same thing. There's some tooling that where you can say, hey, kernel, tell me more about this, right? Many platforms also have DTrace, and that one's better, and I'm going to talk about it tonight. So what is DTrace? It is an in-kernel scripting language. So not just, okay, I've got a command that I can run and ask one specific question, but I can write a program. I can write something that looks like a SQL select query, or it looks like an awk file. I can pass that safely to the kernel. It will get compiled, and it is guaranteed to run in kernel space without crashing the kernel. So that's sort of amazing. It treats the kernel like a database, so you can query any information the kernel knows. The big difference is the kernel's not a database, right? That data is not static. It is very up to the minute. The kernel is moving. The kernel's executing your DTrace program, if nothing else, right? So it is a moving target. So that makes it very weird. So think of it as like a database in motion. So again, yeah, you can express your queries as small programs called dscripts. If you think of it like, okay, it's SQL or awk for the kernel, that's the right way to think about it. It's safe. I can't emphasize this enough. You can, if you are an administrator, let your developers walk up to your production systems and DTrace them. They might be able to see something. They might, because it runs in the kernel. There's no limits on what you can see with DTrace. So you might not want that from a security perspective, but you are guaranteed that they cannot write a DTrace program at all, no matter how bad, that will crash or slow the system down. You can instrument all layers, networking, storage, even language runtime. So there are some adapters that will contextualize what's happening in the JVM, or will tell you, not just like, okay, Postgres made this IO call, but this table action is happening. Postgres is vacuuming right now. So you can get some application context out of this together with kernel context, even for third-party and closed-source apps, right? So this is cool. So let's say I'm not running Postgres. Let's say I'm running SQL Server, and I want to know this information. I can't get that domain-specific context out of SQL Server if Microsoft doesn't cooperate. But I can still understand from the kernel's perspective, well, maybe not SQL Server, some other, Oracle, that's a great one. Okay, I'm on Solaris, I'm running Oracle, okay? Oracle's obviously not cooperating because Oracle does not cooperate. But I can run Oracle on Solaris with DTrace. I can understand what that database is asking of the system it's running on. So I put together this excellent visualization to show you how this works. So what you, as a person who is responsible for a slow system, right? And here's why slow systems are bad. When a system is obviously broken, that's bad, right? That costs money, you know, that costs us downtime. We have to go fix it. But when it's obviously broken, you almost always know what the answer is, right? Or it's very clear what resources are not being met. When something is just slow, like it's right, it's doing the right thing, but nobody's happy, that's worse because why is it slow? What changed? It was fast yesterday. What on earth changed? So you can write a DTrace slip called why so slow.d. You hand this off to, okay, good. Yeah, I'll hurt you real hard on this. So DTrace compiles it and sends it to the interpreter, which sits in kernel space. That can then query all these kernel resources like network or file system or whatever else. And then it can do aggregation just like awk and SQL can and hand you back some meaningful data so you can get live insight into your running kernel. So I will do a small demo. I have to switch between presenting and my console. So let's see if I can do this correctly. Sorry, 1 second. I practiced this on one monitor. Okay, so let me hop. Oh, now I got to do this. Oh, wait, hold on. I've got another. I'm so sorry. I'm like trying to find where my mouse is. Yeah, okay, good. Now I can see what you see. Okay, so here's what I would like to do to show off what DTrace can do for us. So you see, can everybody see in the back? Okay, okay. No, make it bigger. Okay, here, I'll make it a little bigger. That good?
That didn't make that one bigger.
I'm like, it's huge right here. Okay.
Yeah,
It looks like Caleb's shell game right now.
Caleb's shell game. This is an improvement on Caleb's shell game. That was the original source. Okay. Is that any better? Okay. So, all right. Here's what I can do. So actually, let me address this split. Yeah, okay, that's what I wanted. So I have these scripts. They end in .d. There is a programming language called D. Not what I'm talking about, right? That was the DTrace comes out of Sun Microsystems, like all things great and wonderful. And you know, the error of Sun Microsystems was that they were so full of themselves that they didn't see what else was going on in the world. So they invented this thing called DTrace and made this language called D without understanding that a lot of academicians were putting a lot of work into a C++ replacement called D. So again, that was their oversight. But there's 2 Ds, and this is the cooler one. So here, let's look at this. So it looks just like awk, right? I have a predicate match over here, and that tells me I'm telling the kernel proc exec success. One thing that sort of stinks about DTrace is you have to know there's like a whole bunch of new names to go learn, right? But it's effectively tables like SQL. So the kernel has all these the kernel's aware of processes, it's aware of threads, it's aware of memory. So all your kernel resources have these sort of sub-properties. So that together is called a probe. So if I want to know about processes that have executed successfully, then the probe I want is proc exec success, right? So think about proc as a table of processes, and exec success is a column that says I successfully executed. So for every match of those events that happen, what I want to do is print. Again, this is super obvious, right? You would just know, you wouldn't even have to Google that, right? That's second nature. So you have to know some of these. They're a little implicit. Fortunately, it is all in the DTrace man page. So it's there for you. But effectively, what this tells me is what's the name of the program that was executed, right? That's really what I want to know. So exec success will tell you the name of the program that was executed, and what arguments were given. So let's watch and see this happen. So I'm going to execute that. All right, so that's just running. I didn't say watch this program. I said watch all programs on the system. So what I'm gonna do is split the screen this way, and I'm gonna log into this system. So I've got a separate console, and I'm gonna log into this system just to understand what happens when a new user SSHs into the system. Does anybody know what happens?
Actually, quite a lot.
There's quite a lot, and it's different on every platform. I did like shell login tech support for a long time, and I thought, I'm like, yeah, SSH just does bash and you're good, right? Yeah, there's a lot going on there. So I'm gonna log in, and then we see what all happened on behalf of that user. So I'm logged in, SSHD forks, first off, that's weird, I didn't know that. So that's part of process isolation, and that's so that you, if you do anything malicious, can't crash the SSHD server for everybody else. So then it checks your quota to see whether do you have any disk space available before I try to log you in, prints out the message of the day, and then checks your local mail. I didn't even know I had local mail on this system, right? So that's handy. So that's sort of like, this is, yeah, there's other tools that can give you this, but this is just an easy way to sort of find out, like, what is everything else doing behind the scenes? What about when I run man? What does man do? It should just load a man page, right? Okay, so man actually also does a lot of stuff under the covers. So that was a learning thing for me. Like, there's not really, like, it actually just unpacks another file, sends it to an interpreter called mandoc, and then sends it to less. So who knows? Also, here's a neat thing I found out. I run the program which. Where am I typing? Come on, computer. I'm telling you, they're too hard to understand. There's too many of them.
So I can
Which?
What's
going
I
on?
wonder if Echo's off, because you killed less.
I killed less.
So Echo's probably off.
SDTY.
Echo.
No, just reset. Enter, reset, enter.
Are you doing this presentation right now? Okay.
Oh,
Okay.
wow.
All right. So, what did I want to do? Oh yeah, which should just start user bin which, right? No, it's an alias to C shell. I'm in bash. Are you telling me bash doesn't have its own which? This is the bash expert, by the way. This guy wants to use a shell that doesn't even have which built in. Give me a break. Okay, so here's another thing. So let's look at something a little more complicated. I have got the tmux source code sitting right here. When I configure, does anyone know what happens when you configure something from source, roughly? Lots of stuff. What all stuff is that? So now we can just watch, right? So as there's tons of stuff, look at all this stuff that's happening. So effectively, this is what I noticed when I was watching this earlier. So this errors, never mind the error at the bottom. I don't care that lib event's not found. What I'm trying to figure out is like, what all is /configure actually doing? It's calling a bunch of sed, bunch of sort. It actually calls GCC a lot, which is weird because I'm preparing something to be compiled. I'm not compiling anything. So I wrote another script, and let's look at that other script called Snoop GCC. So I'm gonna pull that up so we can look at the code. So this is just like the previous one, except I've got this filter on it. So again, just like awk, I can filter based on property names. So if the exec name or if the process name is GCC, then print the line. So that's the only difference. So now I'm gonna run my Snoop GCC, and I'm just gonna see how many times does GCC show up when I call configure. A bunch, and it's compiling the same file over and over again. What is this? So I looked it up. What's actually happening is when you configure, when it says checking for strlcat, checking for stern dump, all those, what's actually happening is it's building a tiny little C program and sending it to the compiler to see if the compiler knows how to build that. So when it's checking for something, it's not like looking on your file system, checking for headers. It's sending a little program to GCC and saying like, I can't find the header. The important thing is, can GCC find the header, right? So that's actually what's going on. So then I've got one other little program here that, because how many times was that? A bunch, I don't know, and I don't have a lot of screen real estate. You don't have to, because in DTrace, like in awk, I keep saying it's like awk. It's so much like awk. We can count these things. So I can declare a variable at the top. It's like awk for C programs. So it's got like all of C's like primitives and data structures, you could do those in DTrace. So that's the difference. Awk is just strings, which is good, but not enough for what we need here. So I want to count the number of GCC invocations. So then my action this time, when I match something, when a process execs successfully and it happens to be named GCC, I'm going to increment this by 1. And that should tell me how many times GCC was called before I even compile anything, by the way. Keep that in mind. And then this special probe right here fires at the end of your DTrace program and tells you how many times GCC was called. So, old count GCC, oldie but a goodie, one of my favorites. Okay, so I let that run. Again, I don't have to point this at anything specific. I just start this on the system and it listens. So I'm going to configure again. Okay, I'm running, that crashes, that's fine. Now, this doesn't know that I'm done. It's just listening, right? Some other user might be on the system doing some more stuff. It's still gathering these statistics. So to get it to print, I kill it. GCC was called 92 times. Before I compile anything that I intend to compile, GCC was invoked, the compiler was invoked 92 times. That's the kind of stuff that you just don't see most of the time. And then when the computer starts to act weird, you don't know why, because you don't know the stuff you've never seen, right? So to me, that's really the power of DTrace, is it helps you, or dynamic tracers in general, but DTrace is cool for some other reasons that we'll get into later. You can just see all this stuff. It's just this visibility is very empowering. Okay, so enough of that. So you've seen a little bit about what we can do. Now, how do I safely get back to my slides?
Just swipe over your space.
Well, no, because
Sounds like a shiny
Nope.
thing.
yeah, okay, all right. You've seen the exec success demo. Okay, D programs, poorly named. There is already a D language. Like awk, but for structs and functions. I think I've said that like 16 times. It's because it's true. So you've got 3 components in each. Your program is just a bunch of statements. There's not logic. There's not like functions or loops or any of that, because that's the kind of stuff that, is anybody familiar with Turing's halting problem? So Alan Turing had that that tape, that infinitely long tape. And some other mathematician was like, how do you know that your algorithms will complete? And so he worked on it, and then he was like, I don't know, I think there's some problems that I can't guarantee will complete. Well, those problems have loops in them, or they have complicated branches. So DTrace, because again, the kernel has to be protected at all costs. You cannot crash a running kernel. So DTrace can't have a program that won't end. So the language doesn't allow you to express that stuff. So that's easy, that's good, because then the programs are much simpler to understand. So you have these probes, predicates, and actions. So again, the probe is like a table, that's your source of information. Your predicate's like a filter, it's like a where clause or a pattern in awk. And then your action is either print something or make a measure of something. What's up?
Question.
Yeah.
Earlier you mentioned I can give dev DTrace and let them run wild. Great.
Yes.
Security hate that. To access the kernel space, though, won't they already have to have elevated permissions?
You would have to elevate them to do that. When I say you can let a dev do it, what I really mean is you can let them write a DTrace script and hand to you, and then you can run it without really having to understand it. You can safely, you don't have to worry that they've handed you a bomb.
That they wrote
Crap, right. It might not give you numbers that are not correct because they've done bad math, right? Anybody can say, yeah, it's, 93% used by whatever, but you don't have to worry about them taking down the machine. Okay. So a more specific example. So I took the Zoom example out, and I'm real sad about that. But so suppose you come to LOPSA and you want to give a talk, and you've got Zoom on your system, and you're recording locally like I was doing foolishly earlier, and then your system's like, oh, got so much going on. And you want to see what all files are being opened, because Zoom opens a lot of temporary files while it's running. You can, because Mac OS has DTrace, you can run this locally, and you can find anytime a program is calling open something, open socket, open file, whatever resource, anytime it starts to do that, and it is named Zoom, then I can just say Zoom open something, right? You do this and you start running Zoom, and it's just like way more often than you would think. In my mind, because I don't know anything about video, right? I'm like, okay, it's gonna open a file and just write all the video in one, No, that is apparently the wrong way to do video streaming. So I don't know anything about it. I don't pretend to, but with DTrace, I can find new things to look up. I can find new things to educate myself about and get a better grasp on what I don't know. Who was the guy? What was the guy? You don't know, the unknown unknowns. You know what I'm talking about.
Dick Cheney.
Dick Cheney. Dick Cheney. You can know the unknowns with DTrace. Donald Rumsfeld. So this is DTrace for Donald Rumsfeld trace. Let's let you know the unknowns. Okay. So
it's all my
yes.
years of doing strace and then grepping through strace to find.
Are absolutely valid. That is a great way to answer a lot of questions. This is an improvement over that, but there's not, boy, a lot of people have gotten a lot of work done that way, right?
Well, half the time I go, I know I'm looking for an open.
Like,
what file is it trying to open? Like that line right there would save me a lot of time.
And this asterisk, this ability for DTrace to sort of like match arbitrarily on things, because again, I keep saying this is like a table, because what it can do is it can say like, well, I'm going to look for any data sources that sort of look like this. So imagine if you could select against like a bunch of tables at once, but with which you can, but without actually having to know what they are, what their structures are. So that's sort of cool. So it has got that like freewheeling loosey-goosiness. So again, I've been talking a lot about like kernel stuff and understanding what the system's doing. What if you're running an application, right? Like you're not making money running FreeBSD in production, right? There's an application sitting there on top. So in order to really understand that, you have to, unless your developers are writing in C, DTrace has got to have some help to know about that, right? Because if DTrace looks at Ruby and it's like, yeah, here's all the C things that Ruby's doing, that's not gonna, you're not gonna have, a line of communication with your developers because they don't know about malloc, right? They're like, I don't know what's going on there. So a lot of modern languages have DTrace probes. So when they are running and only when they're running, this is available. This is, again, it's like extra tables that you can select from, right? So, so that's neat. You can mix and match kernel and language probes to get a full top to bottom understanding of what this developer's awful software is doing to your machine live in production. So it's great. So to show that, I'm going to show some Python because I have forgotten all my Ruby.
That's probably for the best.
You know what? You may be right. Okay, so I'm going over here. You'll have to, I'm so sorry, this is slow to switch these. Okay, so now, and then I get myself, where's my cursor? When I was young, my mother would be like, oh, I can't find the mouse. Robert, where's the mouse? And I'm like, what's wrong with you? And now I'm like, I'm 32 and I can't find the mouse on my screen. It's all, computers are bad. It's not.
Ever use the control shortcut in Windows to find it?
I don't use, come on, man, give me a break. All right.
Oh, God.
Don't poop where you eat.
If you wiggle it real fast, it gets big.
Yeah.
All right. This is a family environment. Okay.
It's a feature.
That's a feature. Okay. So this is a little cramped. Let me, I apologize. Forgive me for the crudity of the model. Let me rearrange real quick because I want to, I didn't want it to rearrange like that. Dang it. I'm going to have to split off. That's fine. So, okay. I've got a Python application. It's a Python Flask application. Let me show you my application. It's a little storefront. So when you go, it's got it's a web program. So there is a greeting page, and these are text pages. So we're gonna browse the web from the terminal, right? It's real fancy. So when you go to my store, it says, hello, please buy something, right? Because I want a lot of customers. And then to order something, a customer needs to go to the URL /purchase/ their credit card number, right? They type that in. It's totally PCI compliant. So, and it's PCI compliant because I said import PCI, right? So we know it's good. And then send payment card number. It's legit, okay? And then very importantly, we want to thank the user for their purchase, right? If you don't thank your customers, you will not have return customers. So this is the application. So we're gonna make a lot of money on this. It is running on the right side of the screen. And I'm going to, if you will forgive me, open a new split, and I'm gonna curl. So for those of you that don't know, curl is it's a command line browser. Browser is a strong word. It will do 6% of what a browser does, which is just make the request, which is all we care about. So this box is called a Lumos, and this service is running on port 5000. So I go there, says, hello, please buy something. Okay. So I want to make a purchase. So we got a purchase. What's your credit card number?
41000
41000
000
000
0000
Okay.
0007.
00. Okay. All right. Thank you for your purchase. So that's succeeded. So that's great. Okay. So as a developer, we're happy. As a business person, we're happy. As a security person, I've got some questions, right? This is looking a little weird. So the security person comes up to you and they're like, do you know what they're doing? What is this? What is this? What's going on in PCI send payment? Well, you know, we're admins, not developers or security people, right? So this is like, I don't know, but DTrace can help us, right? So we can just look at what it's doing, because if it's sending payment, maybe it's going over the network, or maybe we see something that says like TLS, I don't know. So we're gonna look. So what we're going to do, I'm worried about my screen real estate for this demo, my goodness. Can you believe I practice on a gigantic monitor? So let's look at, so here's my DTrace script that I've written for this. So this is Flask Snoop. I forget which one comes first. How do this isn't gonna look pretty. Oh my goodness. Okay, all right, hold on. One second. I'm so sorry.
Yeah, you control screen.
Yeah, it is, but the thing is, if I do it in the middle of this presentation, I will hit a fat finger and then I'll close a window and then I won't be able to get back. This is like, I prepare for my presentation by spinning up a lot of state by hand, and then I am too scared to wreck it. So, okay, here we go. So I've effectively done the long way of what Caleb suggested. So in payment gateway, okay, Flask Snoop. Okay, so what this does, this exposes our Python bindings. This Python star looks for any running Python program that has got DTrace built in. Most of the time, if you just install Python, it's got DTrace by default, if you're on a platform that supports DTrace. If you are building it for an embedded system, you definitely want to strip that out, makes it slower, or makes it smaller in terms of memory footprint, but usually you've got it by default. So I'm looking for function entries, because that purchase function is what my security person is real concerned about, right? Because that's where we're handling customer credit card information. So we just want to see where all that gets called, and we're going to print this. This is sort of like garbage to look at. Don't worry about like learning DTrace, the language from these slides. You're not going to look it up later. But what this is going to do is print out the file name. Whenever we hit this function, it's going to say this function was hit in this Python file, right? And that will help us dig later. So now so I want to run this flask snoop.d, okay? Squeeze me, oh yeah, I got to tell it what, so purchase. Okay, so we matched one probe. If DTrace says it matches a probe, you're in business. If it doesn't, you're okay, you're just not going to get any results. So now I'm going to curl again, so I'm going to make that purchase again. Okay, I'm getting some results. So that's good. So it's showing that, I'm so sorry that this is chopped off. If I can duck, it's showing that it found the purchase function in my.py on line 6. So I can look at that, and we can also see when I just other accesses of the service. So again, this is a live service. They don't get hit by DTrace, right? And that's good, because I only want to instrument a very narrow part of if you instrument the entire application, it may be like that bad SQL query that slows the database down. What DTrace will do is it will say, you're eating up too many cycles, it will eject your program. It will say, cannot complete your program, or it will say, dropped probes, which means you could have gotten some results during this last counter time, but it would have slowed the kernel down, so I didn't give them to you. So again, DTrace will protect the kernel at all costs. So this is neat. So if I'm a normal user, if I'm not doing anything sensitive, no tracing. If I'm doing something sensitive, then I get that trace event. So I know something's going on there, and I want some more information about it. So now what I'm going to do is I'm going to look at another program that's a little bit more complicated called Flask Trace. And what this effectively does, again, my poor screen real estate. Okay. I'm not going to walk through and explain this except to say that if you can imagine, as I descend the stack functions, I sort of like indent a little bit, and then as I exit functions, unindent a little bit, right? And you can sort of get that Christmas tree, right? Developers will see this all the time. Like anytime they hit a bug, they get a backtrace, they're like, yeah. Now, without really having to understand the application, you can sort of get a sense for what it's doing. So this is cool. So I'm going to run flash trace, okay? Oh yeah, I keep forgetting, I've got to tell it purchase. Thanks, Andy. Okay, so now I'm going to watch what's going on in this stinking purchase. So it's not, I've set it on quiet mode. So it's not going to tell me I've matched probes, but I happen to know already that I did match some probes. So again, normal, nothing. I'm going to do a purchase. Okay, well, so I've got some results. So let's look at what's going on here. So I see something funny right here. These sneaky developers, B64 in code. What are they doing? Are they thinking this is encryption and it's not encryption? So that smells a little bit. So let's keep looking. Let's see what else is going on here. Control B. Okay. All right, so let's go up to the top. So we see here, this is the purchase function. It goes into PCI send payment. So that's interesting. Apparently that's our code and not something that was imported from the vendor. And then it starts going into codecs and then base 64. So no network, no, like, what are these people doing here? So now the security person's like, oh yeah, this is a common thing that developers do. They don't know what encryption is. They base 64 encode something. Management can't tell that it's not encrypted. And so then everybody's happy, right? Well, everybody's not happy because we can get sued. So now that we have this insight, again, without having to dig through the source code, we have this insight and it's enough to smell a problem. So we can quit here and then we can go, now that we have some suspicion, we're gonna go look and see what these developers have been up to. Look at PCI.py, boom. They are taking the credit card number, encoding it, calling it ciphertext, which is wrong, and then saving that to a file. So now we know somewhere in our system is unencrypted credit card numbers. We are in a lot of trouble, but we can stop the bleeding before it gets any worse, right? We're able to find this, we can find this problem, possibly even fix it without taking the system offline. So that's cool. So again, so that's what you can do with language bindings. So I'm gonna go back to my slides. Hey, come on, Keynote. Okay, so recap thus far on what DTrace does. Scripting language, the interpreter lives in the kernel. It's safe. You can ask hard questions without crashing the kernel. Traces all software, kernel, apps you wrote, apps you didn't wrote, okay? So now you may wonder, where can you get this for yourself? So DTrace, of course, comes from Sun Microsystems, like I said earlier. So Open Solaris became open source about 2005. After that, FreeBSD picked it up. The Solaris and BSD kernels have some common heritage because the dude that started BSD at Berkeley founded Sun Microsystems, so they're a little bit in common, right? So FreeBSD picked that up. Because FreeBSD and macOS have a lot in common, Apple picked it up a little while later. So if you do, or if you know anybody that does any iOS app developments, they have some GUI tools that they use for performance analysis that actually use DTrace under the hood, right? So Apple doesn't make a big deal about this because they don't like the scripting language. It's not pretty. So they have some graphical tools, but they are using the DTrace virtual machine under the hood to do that performance analysis on watchOS, tvOS, iOS, macOS, all of that. So DTrace is everywhere. And so you might be thinking, well, this is on Linux, right? So that's the big announcement, right? It's like I've gathered you all here today to tell you that it's on Linux. In fact, it is on Windows. So Microsoft has released DTrace for Windows earlier this year, and it is still not on Linux. So that sort of blew my mind. I thought, this is the end of the world. This is cats and dogs living together in harmony. But no, Bill Gates said, I want to bring this to GNU. GNU is Gates's non-Unix, and so now we have DTrace on GNU, right? So now the circle is completed. But seriously, why no DTrace on Linux? This guy is the main problem, right? He creates a lot of fear, uncertainty, and doubt around the GPL. Specifically, what does a derivative work even mean? It's unclear. So a lot of the stuff that came out of Sun Microsystems that's open source is licensed under what's called CUDL. it's not clear. It's very clear to some people that CUDL and GPL are incompatible. It is equally clear to other people that they are absolutely, totally compatible. So none of the people I hear arguing are loggers, so I don't know, right? All I can say is I don't know. The Linux kernel, Linus has said, I'm not taking DTrace and I'm not taking ZFS, which is another thing that's come out of Sun Microsystems, right? There are other people that are putting those things into Linux, so we can talk about that, but it is not in vanilla Linux. Who wants to risk being wrong? And then this bozo sues you, right? By the way, this is an actual photo of Stallman dressed up as a character called Saint Ignatius. He's a maniac. Okay, so here's the long answer is, if you are an Oracle Enterprise Linux customer, you have DTrace. Oracle bought Sun, they own all the IP, they're not gonna sue themselves. So you have it there. I don't know, but Oracle's doing it. There is a single British gentleman who takes the Linux kernel, and every time a new kernel comes out, he patches DTrace onto it. So he hadn't done it this year, but he used to do it, and maybe he'll start doing it again. So you can get that. Has to be manually merged, not so much. There are alternatives on Linux, so we need to talk about those. SystemTap does very similar things. It doesn't have all the language bindings. Python has language bindings for SystemTap, but that's it. Ftrace is on Linux. Ftrace can do like 60% of what DTrace can do. 60% is a lot, right? People used to say about GIMP, it can do 80% of what Photoshop can do. Well, that's still a lot, right? It's not Photoshop, but it's free. So Ftrace may be a good tool for a lot of your problems. eBPF is the new hotness. So this is where things are going in Linux. This is a low-level virtual machine. eBPF, you're like, this, it's not like a language so much as it's a bytecode interpreter. So you have to write eBPF assembly and send it to the kernel to be able to ask those questions. If you know how to do that, if you have a language that can compile to that, if you've written all of your own tooling for that, you're in good shape. Well, Netflix and Facebook have, right? But the rest of us don't have this. So BPF trace, Brendan Gregg wrote a few books on DTrace a long time ago when he worked at Sun and then Joyent after that, but now he's at Netflix, and Netflix has a lot of FreeBSD caches locally, and they do a lot of Linux on AWS in the cloud. So he does performance on both. He's betting on BPF trace. It looks like DTrace, but it sits on top of eBPF. It looks promising, but it doesn't have all the language bindings yet. And it is like, it's just still a little like, I expect more, right? But this is endorsed by somebody who knows what he's talking about. So let's talk about DTrace on Windows. It is open source. Thank you, Microsoft. They've retained the CUDL license. They were not required to, but they did. It's not on regular Windows. You have to get Windows Insider. And I was so struggling to figure out how to become a Windows Insider. I was like, I'm gonna have to call Wesley and say, Wesley, can you please let me into the fold? I'm the prodigal son. I've come home after this many years of not using Windows. I'm ready to be welcomed home. Okay, it's only on x86 for the moment, but it still gives you top to bottom custom tracing on everything on the computer, including kernel activity, big asterisk, if you enable the kernel debugger. So hopefully Microsoft, they say that when this becomes properly integrated into Windows, there's some PowerShell signing is a thing. Do you know about that? Yeah.
Yeah, that's kind of like.
Okay. Okay. Well, so the idea is to take that and apply it to DTrace scripts, because these things have effectively become kernel modules, right? So then you sign your DTrace scripts, and so then Windows is like, okay, I don't know about this script, but I trust the signature of this key that it's been signed with, so I'm okay with loading this dynamically into my kernel now. So then we won't have to run the kernel debugger to get all that, but you can still do a lot of stuff without the kernel debugger. And I will give a very quick Windows demo, and then we can go drink. Again, and this is why I was trying to be so careful, because I didn't want to reveal. I've got a Windows VM sitting over here. All right. Oh, Wesley, what happened?
Just change it back.
Oh, I don't have time. It's 6 till drinking. Okay. How do I do this? Settings?
Minutes. Right click on the desktop.
I know, but it's hot and people want to leave.
Not that one.
Oh, okay. I had to like relearn Windows for this demo.
Right click on the desktop.
Display settings
1920 by 1080.
at the bottom.
Yes. Or wherever you want to click. That also works too.
Oh, everybody can see now? Good. Keep changes. Okay. Okay. Thank you, Wesley. Wesley is my tech support for this. Okay. So, so here's another cool thing you can do with Windows, but y'all didn't know this. Caleb had me rename this so I wouldn't give it away, but this is my Windows console. You can SSH into Windows. Did y'all know that?
Yep.
Boom!
I gave a talk on it.
You did?
Yeah.
That was before I joined LOPSA. Okay, so that's old news. That's fine. So I'm running PowerShell. What is going on? It's the future. Okay, so I can run. Which one did I want to do first? I don't have time to figure it out. Yeah, I want to do NT open file. So sorry, let me readjust. Okay, NT open file. So this, all it does. Oh, let me show you the source code first. Sorry. Print type. Okay, not that much to it. It looks for the system call NT open file. Any application that is opening a file is going to have to call that at some point, and this is just going to tattle and tell me who, right? So this isn't very fine grained. This is like not super useful, but if you just like want to, if the system's running slow, it's probably the disk, right? It's like 9 times out of 10 it's a disk. So you can just run this and say like, okay, who's banging on the disk? Let me run it. Okay, matched one probe. I'm not doing anything on this machine. Now keep in mind, I am running this as a virtual machine. So yeah, there we go. When you run in a virtual machine, usually your virtual machine provider has some special agent that sits there so that it can like integrate it into the host OS or whatever, right? So there's some like spyware sitting there. So DLL host, I don't know what this is. What is DLL host?
Honestly,
He doesn't know what it is. Okay, so I got all this crap going on, so that's fine. So I don't know what it is, but I know
DLL somehow.
I know that while the computer is seemingly idle, there's a bunch of stuff. There's a bunch of people using the disk, right? So when my computer looks idle, maybe it ain't. Okay, so that's some extra context that again you just wouldn't see if you weren't looking for it. So I'm gonna kill that because that's not that great. I got one that's a little bit better. So now I'm gonna go over. We're running out of time. We got so tight on time. Wesley? What happened?
Parallels.
Okay, 12 minutes. Okay, we're flying. We're flying through this. This is the last demo. So, except it's not, but it's going to be the last demo. Actually, we're going to skip this one. It's not that interesting. All it does is it tells me I load up a giant image in Paint, and it's like, you've used this many bytes have been transferred, right? Just to give you, to prove to you that I can watch a running application and I can count how many bytes it has read or written, right? And that can tell me a lot about, especially a sick application. If I'm like, this thing is normally steaming, and it's like, in the last 5 seconds, it's transferred 100 bytes. Something's wrong with that application, right? And so that level of visibility can just tell you, not that, because you probably already know a problem exists before you're doing this, right? But it can help you diagnose what part of the application might be sick. So you, as the person in charge, the Atlas holding up the world, can get your feet planted, right? And then keep everything from crashing down. So we're gonna skip this and go to the other one because it's a little better. Boop. Hey, I said change screens. Where's my cursor?
It's trapped in the VM.
I untrapped it. Okay. So desktop. Okay. Yeah, sorry. Slides. Don't tell me it's trapped in the VM now. Okay, all right. Play. And then I gotta hit play twice for some reason. There we go. Okay. All right. Windows demo done. Okay. Hope for the future. Here's what I see DTrace on Windows. This is why I think it's a big game changer, not just because Wesley can do it now. We can have DevOps Harmony with this, right? We can now have common tooling for if you have a DevOps team, this is just extra stuff for them. If you have like developers, operations, security, these other people, then we can now diagnose problems with common tooling and we can agree upon the answers, right? So we can reproduce each other's results. Admins can run DTrace scripts from devs safely. I think that's tremendous. So we don't have to have these post-mortem arguments where everybody's like, oh, it's your software, it's your machine, or what, you know, we can agree. We might not agree on what the root cause is necessarily. We might not agree on whose fault it is, it might be planning or whatever, but we can get the same numbers. And if we start the conversation from the same numbers, we can get to peace, we can get to harmony quicker. DTrace on Windows Server. Microsoft is in a position to add probes for C#, SQL Server, whatever other junk that makes some mail, that make a mail thing of some kind. DTrace on containers. This is where I was, okay, all the Linux people are not here, so they're not gonna get offended. Okay, On Linux and Lumos, DTrace knows about zones. That's what containers are called on that platform, right? So if you got a process, two processes running in two different containers, you can trace them by container or across containers looking at the same type of process, right? So you have that visibility. The kernel knows what the things are, so the tracer can know what the things are. On FreeBSD, DTrace knows about jails, same things. Jails are your container type of thing on FreeBSD. Same level of visibility. Linux, nope. Containers are totally user space entities because the Linux kernel has no idea what a container is, right? There are C groups and namespaces and all this crap, but you can't like necessarily say like, well, this thing belongs to those and not the others. It gets real dicey. So this sort of confusion, I think, does deserve its own talk. Maybe it's possible that eBPF could say like, well, we will allow you to inspect things by like namespace tuple. So you specify all the different namespaces and say like anything that is a member of these or a member of a child namespace counts. But it's not clear to me what that's going to look like. What would be interesting, I want to see what choices Microsoft makes here. They have native containerization. So you can do containers, Linux and Windows containers on Windows without virtualizing. You don't have to have virtual hardware for the Linux containers. So that's super interesting. So Windows may have better container tracing for Linux containers than Linux does. That would be interesting. The real big kicker for me, enterprise desktop support. You can now have, now that DTrace is on macOS and Windows, you have one thing that when someone says, wow, my laptop is slow, it doesn't matter what the laptop is running, you've got one tool that you can use to understand what's going on. Admins and devs can provide descripts to the help desk. Help desk can run these things and, also, again, this allows you to watch network traffic. It allows you to watch access to files. So every big organization has got some kind of like localized corporate spyware, right? And it all sucks and everybody hates it, but DTrace could sort of help replace that because the reason that everybody hates it, it slows your system down because it's looking at everything, right? Well, if you're running in a kernel interpreter that specifically puts limits on how much performance the spyware can consume, then now you can, as an ops and security people, you can get the insight you want without the user noticing, without actually getting in the user's way. So I'm hopeful for that. This is what the future could look like, right? You call the help desk and they say, have you tried running such and such a descript? Or it just runs all the time and sends the data back to the help desk and they know what's wrong with your computer before you even place the call. I'm very optimistic about that. We don't have time for this Zoom demo. Oh, no, I'm not gonna do the Zoom demo anyway. Sorry, I've got a TCP Snoop demo. Sorry, bad slide. And we do have time for that. So real quick, on TCP Snoop. Okay, so changing screens again. Slim pickings, good guy. Okay, so I'm gonna hop. So now I'm pretending to be a user, and I'm saying, I'm like, does anybody know what Little Snitch is? Have you ever heard of that? So Little Snitch is stuff that you can install on an enterprise endpoint that will say, you can either make it block all outgoing traffic, or you can have it alert the user or alert some kind of central reporting thing about outgoing traffic. And the thing that prevents is like a user has gotten some kind of malware on the machine. First thing the malware is going to do is try to make an outbound connection to a command and control server, right? Well, if you can stop that or at least be aware of it, then you're sort of ahead of the game, right? You're not finding out when you get the ransomware notice. You're finding out from your logs, hopefully before that. So Little Snitch is cool. DTrace is cooler. So we can do the same thing with DTrace. Now this is a little more complicated and I'm not going to go through the source code other than to tell you this is about 30 lines of DTrace and I can now get a report. You have to run, DTrace runs in the kernel, so you gotta invoke it as root. My password for this box is, don't. Sorry, I was typing the wrong password. Would you believe that? Okay. Yeah, that's the right password right there. Okay. Split this, and then I'm gonna make, okay, look, what is that? Box. What is box? What is that? Oh yeah, that's that file sharing thing I'm running, right? Okay, cool. So it's already caught that. If I make So again, I make that curl request to that virtual machine that's running. So this is interesting. I make a network request to a virtual machine on my box, and I get activity for that first one, and then these second two processes are actually my virtual bridges forwarding that traffic, right? So I get all this insight about what's going on. So if I had some malware on this box that was attempting to reach out to some foreign host, here it shows up and I don't have to pay $30 per endpoint for a little snitch, right? I've got it in DTrace. It's been built into macOS for 12 years. Okay, that was the last demo. We have 12 seconds for slides, and then we have to go drink. It's state law. And this thing, gosh. Okay, so not Zoom. What is the network stack doing? Okay, summary. DTrace is a powerful, safe way to understand what the whole computer is doing. Language and app-specific probes give everybody common tooling. DTrace on Windows opens up big possibilities for visibility across the enterprise. Linux has some good alternatives to DTrace. They don't do everything DTrace does, but there's a lot of energy going into them. So they could do more in the future, but they don't yet. Any questions?
We have time for one question.
To give me the best question.
Many questions at the
K-Town Tavern. I will entertain all questions there. Who has the worst question? If nobody wants to volunteer the best question, we'll start at the
I've got the worst.
Okay, what's
How
that?
can we do this at scale?
Okay, that's great, right? So everything I've been showing is about like, here's how you can do it on this one machine, right? So the trouble of distributed DTrace is an open research question. The FreeBSD people are putting the most effort into it. Fortunately, now that DTrace is on so many platforms, there is a GitHub project called Open DTrace. That's where Microsoft is hosting their fork of DTrace, is with the Open DTrace project. So Microsoft is playing along, which is good because they don't do that much, right? So hopefully the work that FreeBSD does around like tagging, effectively what they're doing is they're tagging all the probes with like machine ID or transaction ID. So that can help you, like microservices are bouncing around wherever, right? So what would be great is if that itself, whatever mechanism they create for that, is cross-platform, right? Because then you can say, well, now I want to trace this request chain that originated on a Windows box, passed through a FreeBSD host, did some Solaris stuff, and then landed on macOS, right? I don't know, whatever. But you need to be able to see that distributed visibility. We're not there yet, but it's being worked on.
Next 2 minutes, we can do another question.
So you mentioned there's no loops on
Right.
conditionals.
Yes.
So I can have a single DTrace script that could run either on Windows or Solaris or whatever.
So the way you do that is here's the trouble, is that your probes are all named after kernel entities. So even between like FreeBSD and NetBSD both have DTrace, and they have different kernel entities, right? Because they got different. You do defines, and then you say like if it matches, here's this thing that I'm looking for, and you give it a name, and so then you can say like, well, if AF inet is defined, I'm on old macOS, right? Well, if PF inet is defined, I'm on either OpenBSD or new macOS, right? So stuff like that. Probably what you're going to want to do is say like, here's a DTrace script for Windows, and then someone's going to like, oh, here's it for macOS. So we're not there yet. Like something needs to be added to the language that is not ugly to do that. But the way people do that now is with a bunch of defines, just like you do in C. And the people who wrote this are like outright C bigots, right? So they think, well, that's all you need, right? So that's sort of the attitude that's coming from. We need something more elegant needs to happen with that. But at the moment, you just have if-defs, and it looks horrible. But you can add, you very much can take a 30-line Windows DTrace script, because I did this earlier, or take a 30-line macOS DTrace script and port it to Windows in like 5 minutes. You just have to look up, read the Microsoft documentation, read the macOS documentation, say like, I know what I've got here, what's the equivalent over here? It's not as, computers are all doing the same things, all the operating systems really have to provide sort of the same set of features, right? So this is cool. You force yourself to take an operating systems course that you either didn't take or slept through in college, right? So it's been a learning experience. But yeah, that's the weakness right now for sure.
Thank you. We're actually
Thank
out
you.
of time.
Okay.
Like I said, thank you.
Okay.